반갑습니다. 저는 오늘 뜻깊은 자리 사회를 맡은 아나운서 이소연입니다. 여러분 대단히 반갑습니다. 네, 먼저 이른 아침 시간부터 H2Me 컨퍼런스 2024 함께 해주시기 위해서 귀한 걸음 해주신 내외 귀빈 여러분들 그리고 모든 참석자분들께 환영과 또 감사 인사를 먼저 올리겠습니다. 리더 서밋은 수소업계 리더와 전문가 등 글로벌 리더들이 한자리에 모여서 지속 가능한 미래를 위한 비전을 공유하고 또 국가별 수소 정책과 전망 등을 논의하는 자리가 되겠습니다. 오늘은 리더 서밋 1일차로 오전에는 환영사와 키노트 스피치가 진행이 되겠고요. 오후에는 2시부터 같은 자리에서 코리아, 재팬, 차이나 하이드로젠 모빌리티 포럼을 진행한 후에 1시간 동안 패널 토론 시간까지 가져보겠습니다. 자, 그럼 지금부터 H2Me 컨퍼런스 2024 리더 서밋 1일차를 시작하겠습니다. 자, 먼저 이번 H2Me 컨퍼런스 2024 개최를 위해서 정말 많은 관심과 격려를 보내주신 분이 계시는데요. H2Me 조직위원회 강남은 조직위원장님께서 환영사 전해주시겠습니다. 무대로 모시겠습니다. 여러분 따뜻한 박수로 환영해 주시기 바랍니다.
안녕하십니까 여러분. 방금 소개받은 월드 하이드로젠 엑스포 H2Me 2024 조직위원장 강남훈입니다. 오늘 바쁘신 와중에도 이 자리에 함께해 주신 귀한 여러분과 또 많은 수소산업 전문가 그리고 내 기빈 여러분과 특히 기업 관계자 여러분께 진심으로 환영의 말씀과 함께 감사의 말씀을 드립니다. 아마 여러분이 여기 아마 오셔가지고 오늘 그 발표를 하시는 것 같아요. 또 오늘부터 해서 셰브론의 앵드류 밍스터 이사님도 오셨고 프랑스의 수소 태스크포스의 미카 메어더 님도 오시고 또 블룸 에너지의 칼 코틀리 님도 오시고 여러분들이 아마 참석하셔서 바쁘신 와중에도 이렇게 연사님으로 또 토론자로 참석해서 진심으로 감사함을 드립니다. 미래 세대를 위해서는 탄소 중립 사회의 실현은 전 세계적으로 더 이상 미룰 수 없는 글로벌 과제가 되었습니다. 그리고 수소는 이러한 탄소 중립 사회 실현을 위해서 그야말로 필수 불가결한 지속 가능한 에너지 된다는 점에서는 아마 전 세계가 다 공감을 하고 있는 것 같습니다. 글로벌 수소 경제를 앞당기기 위해서는 수소의 생산, 유통, 활용 등 수소 산업 전 주기에 걸친 생태계 구축이 필요하다고 하겠습니다. 이를 위해서는 기업의 기술 개발과 투자는 물론 생태계 구축을 위한 각국 정부의 적극적인 지원 정책도 필요합니다. 오늘을 시작으로 해서 내일까지 이틀간 열리는 리더스 서밋에서는 글로벌 전문가분들이 수소 산업의 최신 트렌드를 전망하고 또 미래의 전략을 공유하면서 관련 첨단 기술 개발, 인프라 구축, 프로젝트 현황 그리고 수소 활용 솔루션 등이 함께 논의될 것으로 생각합니다. 이 행사를 통해서 전 세계가 수소 경제의 미래를 함께 설계하고 혁신을 논의하는 뜻깊은 시간이 되기를 바라겠습니다. 오후에 진행되는 한일중 수소 모빌리티 포럼은 금년에 처음 개최되는 행사로서 한일중 3국의 수소 산업과 모빌리티 동향 그리고 3국 간의 수소 협력 방안을 보다 심층적으로 논의하는 장이 될 것으로 기대됩니다. 마지막으로 이번 리더 서밋과 H2Me 2024 컨퍼런스에 참석해 주신 모든 연사분들 또 수소 전문가분들 학계 인사 그리고 기업 관계자 여러분들께 다시 한번 진심 어린 감사의 인사를 드립니다. 이 자리가 글로벌 수소 경제를 앞당기는 귀중한 장이 되기를 바랍니다. 그럼 이제부터 H2Me 2024 리더 서밋의 시작을 선언하겠습니다. 감사합니다.
네, 고맙습니다. H2Me 컨퍼런스 2024 리더 서밋의 개막을 알려주셨는데요. 미래 세대를 위한 지속 가능한 에너지입니다. 이 수소 생태계를 안전하고 또 단단하게 구축하고 수소 산업을 발전시킬 수 있도록 정책과 또 트렌드를 논의하는 장이 되겠습니다. 오늘 강연과 발표들 여러분 끝까지 경청해 주시고요. 오늘 이 자리 함께해 주시면 고맙겠습니다. 자, 그럼 지금부터 키노트 세션 강연을 본격적으로 시작해 보겠습니다. 첫 번째 연사는 우주 맥켄지의 프린시플 컨설턴트이십니다. 플로르 루시아 데라 크루즈님께서 암모니아 코스트, 인프라스트럭처 앤 이미션이란 주제로 강연해 주시겠습니다. 무대로 모시겠습니다. 여러분 따뜻한 박수로 환영해 주시기 바랍니다. 쉐브론 제너럴 매니저이신데요. 앤드류 밍스트님께서 글로벌 트렌드 앤 스트래티지스 앤 하이드로젠 마켓이란 주제로 발표 준비해 주셨습니다. 무대로 모시도록 하겠습니다. 여러분 따뜻한 박수로 환영해 주시기 바랍니다.
Good morning. What a beautiful couple of days here in Seoul. It's so enjoyable to see the colors of fall beginning to enter into the trees. Thank you. And my thanks as well to the H2 Meet Organizing Committee for the good work here, as well as the very kind invitation. Really briefly, I'm the General Manager for Chevron New Energies for Asia Pacific, responsible for our hydrogen and CCS business lines here within the region. My career has taken me from the United States to Australia, France, Angola, Democratic Republic of Congo, to Singapore, where I'm currently based. Prior to Chevron, I served for 8 years in the government of the United States with the U.S. Environmental Protection Agency, as well as with one of the national labs administered by our Department of Energy. Just for a little bit of context on my remarks today, Chevron is one of the oldest and largest foreign investors in Korea. This is a point of tremendous pride for us. Our major business presence here in the country is through our 50% interest in GS Caltex, along with our very strong partner of more than 60 years, GS Energy. The GS Caltex Yosu refinery down south in the country is the largest refinery in Chevron's system. It's the 5th largest refinery in the world with a capacity of 800,000 barrels per day. Chevron's crude and product supply chain is integrated with the refinery. We supply up to 50% of the crude, and we purchase up to 50% of the refined product for export to other countries here within the region. GS Caltex also has more than 2,200 retail sites across Korea, with an approximate 25% of the market. And at these sites and others, there are some 3,200 very hardworking employees, and it's, again, a source of tremendous pride for us to attract that kind of talent. I am preaching to the choir with the content of this slide, but the front end of a hydrogen conference is probably not a bad time for us to beat our chests just a little bit. Hydrogen is attractive, of course, because it is abundant, and because when it is used in a fuel cell or a boiler, a furnace, a turbine, it produces no carbon dioxide emissions. For an owner or operator of a, let's say, gas-fired power plant in Korea or Japan, hydrogen can authentically take your CO2 emissions to zero. I say authentic to respectfully differentiate hydrogen from carbon offsets, where your emission reductions are generally taking place in a different geography and almost always taking place in a different sector. And I emphasize zero to differentiate hydrogen from, let's say, natural gas, which policymakers in most nations view as an absolutely critical bridge in the energy transition, but not necessarily as the permanent solution. With the, again, very knowledgeable crowd in attendance today, we could probably spend a lot of time talking about the many barriers to the growth of a vibrant, lower carbon hydrogen or ammonia market. And indeed, there are many challenges and many barriers. Chevron, as a supplier, faces a unique set of challenges. So too do our end users. The considerations by policymakers and regulators are also quite distinct. But where I believe we have common ground is on the shared goal of driving down lower carbon hydrogen or ammonia production costs and increasing the competitiveness with conventional fuels. And to that end, you'll see some similar themes here with our previous speaker. There are a couple of very critical enablers that rise straight to the top from Chevron's perspective. First and foremost is policy support. Whether on the demand side or on the supply side, financial incentives are absolutely critical to mitigate the risks and bridge the still very significant gap to profitability. These incentives, in our view, they need to be material, they need to be durable, meaning long-lasting, and they need to be relatively easy to access. Otherwise, the available capital will continue to flow to more conventional investments as companies seek to maximize their shareholder returns. A second enabler is technology. Given the sheer scale of the climate challenge, given the energy security concerns that are always prevalent throughout the world, it is our view that an all-of-the-above approach to solutions is warranted. Where we operate, we very strongly urge governments to avoid the temptation of trying to pick a winning technology and instead aim to keep all lower carbon hydrogen production and transportation pathways open. Third enabler, again, recognized by the previous speaker, recognized, I'm sure, by everybody in the room, partnership. From our perspective, there are two key pieces here. First, very few companies have all of the capabilities necessary to be successful in this space. And second, where we can share infrastructure, that becomes an important tool to drive down hydrogen and ammonia production costs. For both of these reasons, strong partnerships are, in our view, a really critical enabler. That includes partnerships between industry and government. So look, at Chevron, our energy transition strategy is twofold. First, to be a leader in the cleaner production of traditional hydrocarbon fuels, which we do believe will be in high demand for many years to come. And second, to grow these new low-carbon business lines that'll play a larger role in the energy future. For the former, Chevron is actively working to decarbonize our existing upstream and downstream oil and gas assets, including our refineries here in Asia Pacific. With respect to the latter, lower carbon new business, we are selectively investing in a few areas. You can see them here: renewable fuels and products, lower carbon hydrogen and ammonia, carbon capture, utilization, and storage, and select emerging plays, I would say in particular the next generation of geothermal technologies. These are all areas where we possess core capabilities and where we think we can compete and ultimately deliver better value to our customers. And look, Chevron is walking the talk, putting its money where its mouth is. You can call it whatever you want, but the numbers are quite large. $10 billion in planned capital investment between 2022 and 2028, $2 billion of that directed into the decarbonization of our assets, $8 billion directed into these new lower carbon business lines. So what are we actually doing with hydrogen? Today, Chevron owns and operates industrial scale hydrogen production units, capacity of more than 1 million tons per year across our company-owned and joint venture assets. For perspective, we make enough hydrogen at just our 2 refineries in California to refuel about 200,000 passenger vehicles, 10,000 commercial vehicles every single day. For these new business lines, we're focusing our growth initially on 2 geographies. The United States, for many of the reasons that were outlined by the previous speaker, as well as here in Asia Pacific. These are locations where we have an existing operating footprint and an existing customer base, very logical places for us to start a higher risk and more uncertain business. Additionally, these regions are attractive to us because of the policy enablement, either in place today or expected to emerge. That includes policies on the kind of pull side, like the subsidies for lower carbon hydrogen and ammonia in the United States, as well as on the push side, like the anticipated increase in the carbon tax in Singapore, making hydrogen more attractive to end users. And finally, like others, targeting 3 primary sectors: power generation, including stationary fuel cells, hard-to-abate industrials, steel, cement, several others, and heavy-duty transportation in particular, which includes, but it's not limited to, the marine bunkering of ammonia, which is an area around which we are quite optimistic. As part of our strategy, we are very much focused on the development of integrated value chains. And like others, we are very attuned to our strengths. We're also very attuned to our gaps, seeking partners that bring complementary capabilities. When it comes to blue hydrogen, relevant here, of course, are Chevron's equity natural gas positions around the world, including here in Asia. Second, we have deep experience with methane reforming. That's, of course, the production pathway in use in our refineries today. Chevron is very experienced with carbon capture and storage. The company has developed and now operates the largest CCS project on Earth, offshore Western Australia. And of course, we have deep experience with the marine transport of liquid and gaseous fuels. This combination, this breadth across the value chain is not an offering that a lot of other companies can provide, at least not on their own. And to highlight that, maybe when it comes to green hydrogen, renewable power is not one of our strengths. We deal principally in molecules, right? Not in electrons. So to advance that more premium product, of course, we're looking for strategic partnerships to get those projects up and running. In short, we are active across the value chain, working with strategic partners where that makes sense, to position ourselves to provide whatever color, whatever carbon intensity our customers want to run their business. Up on top, we are pursuing commercial scale co-development opportunities with a number of partners. I'll give you 2 examples in just a moment. Here in the middle, recognizing the, I'm sorry, it looks like some of the logos have disappeared, that's all right. Recognizing the critical role of technology in driving down hydrogen production and transport costs, driving down the carbon intensity of hydrogen production, we're very active through our venture capital arm. And finally, down on the bottom, as part of our efforts to, along with many others, foster the development of a hydrogen economy, we are working very actively to propagate demand for the fuel. And to give you an example, with the truck maker Cummins, we are working to bring to our shared customers, which in this example could be commercial vehicle fleet operators like Chevron, Amazon, the hydrogen fueled truck, the hydrogen fueling infrastructure, and the hydrogen itself, all at the same time. very much a lesson learned from the deployment of battery electric vehicles, including in California where we're headquartered, where you often have the vehicle but not the infrastructure, or the infrastructure but not the vehicle, something of a chicken or the egg situation that really slowed penetration of the technology. Still, on this topic of value chain, for just maybe the last two slides here that I have in my presentation, I want to take a moment to just state the obvious. When it comes to blue hydrogen, the challenge is not making the hydrogen. The challenge is injecting that CO2 into underground storage formations and then keeping it in the ground in perpetuity. So as we look at blue hydrogen projects around the world, our advice is look not just at the producer of the hydrogen, but at the storage locations, the owners and operators of those locations, to gauge those projects in their entirety. In the US Gulf Coast, Chevron is the lead developer and 50% owner of the Bayou Bend CCS project. This is one of the largest CCS projects on Earth, certainly in the United States. We are in association with the Bayou Bend project in the early stages of considering an ammonia production and export concept, with more details forthcoming as we move through the year. We're committed not just to a blue product, however, but also to green. And with Mitsubishi Power Americas, we're advancing ACES Delta. This is a green hydrogen project development platform in the western United States, state of Utah. The project objective is to produce and deliver to a 1 gigawatt gas plant hydrogen for onward dispatch of lower CI electricity to end-use customers in Los Angeles, California. Our project scope includes the development and operation of 220 megawatts of electrolyzer capacity. Back on my cover slide, that was a photograph of some of the electrolyzers on site, as well as development of balance of plant facilities. We are also developing, in association with this project, 2 very, very large underground hydrogen storage caverns, which we're solution mining from, again, very large salt formations. For perspective, in each of these 2 underground caverns, you could fit the 102-story New York Empire State Building, or to use a more local example, any building here in downtown Seoul, with the exception of the very tall Lotte Tower. The project took FID back in June of 2022. This photograph is about a year old. We expect to commission this project late this year, early 2025. With those 2 examples, I will close. I'd like to really thank you for your interest and your attention. I very much look forward to the speakers to follow, as well as the country sessions occurring in parallel. Thank you.
Thank you very much for your presentation. 여러분 다시 한번 오늘 소중한 발표해 주신 앤드류 밍스트님께 큰 박수 부탁드리겠습니다. Please give him another big round of applause. Thank you very much. 수소시장의 세계적인 트렌드, 또 쉐브론의 전략에 대해서 말씀을 해주셨는데요. 정책적인 지원과 또 파트너십 중요성에 대해서 다시 한번 말씀해 주셨습니다. 고맙습니다. 자, 이어서는 3번째 연사분의 발표가 있겠습니다. 프렌치 하이드로젠 태스크포스의 하이드로젠 마켓 어정트 렉처이십니다. 미카 블루지온 메레드님께서 오늘 발표를 준비해 주셨는데요. 네, 혹시 발표 자료가 준비가 됐을까요? 네, 고맙습니다. 미카 블루지온 메레드님께서 오늘 발표에 수고해 주시겠습니다. 여러분 따뜻한 박수로 환영해 주시기 바랍니다.
안녕하세요. 제 이름은 미카입니다. And I'm really happy to be here again for the 3rd year in a row at H2 Meet to share some of my research. I just have one request for you guys. I have 58 slides for you and 20 minutes only to go through them, so pay attention. And second request, last year I could attend Blackpink's World Tour last concert right after H2 Meet. And this year, none of my favorite K-pop groups were organizing a concert after H2 Meet. So please tell Ive, tell aespa, tell New Jeans to organize a concert next year after H2 Meet. Anyway, on that note, I would like to start by paying an homage. Please raise your hand, those of you who recognize this man. Raise your hand, please, if you recognize this man. Okay, not many hands raised here. This man's name is Nejat Veziroglu. He's Turkish, and he just passed away earlier on this month at the age of 100 years old. He is known as Mr. Hydrogen Romantic. He is the founder of the IAHE, the International Association for Hydrogen Energy, which is the leading knowledge society, scientist society in the world on hydrogen. It was founded 50 years ago in 1974. He just passed away, and the reason why I want to pay homage to him specifically here is not just because I'm the green hydrogen ambassador of this mighty organization. It's also because he was instrumental to Korea harnessing hydrogen. He is the one person who, in the early 1980s, went here to Seoul and convinced the then chairman of Hyundai to actually develop research and development at scale on hydrogen, leading to Hyundai's early innovations in 1987, 1989, 1990 on hydrogen cars, for example. So really, I would like to just applaud him, if you will, please. On that note, I would like to remember why we're here talking about clean hydrogen. I travel the world, and my carbon footprint is not that good. And on all of these hydrogen conferences, we talk about business, we talk about money, we talk about big projects, potential and whatnot. We most certainly very often forget to talk about why we're here. This is the hydrogen industry today. So the starting point is not glorious. There's a lot of gray hydrogen that needs to be decarbonized here first and foremost. That's the first off-taking route for hydrogen. But to do that, of course, you need green hydrogen or clean hydrogen to be produced at scale. And of course, we're not there yet. The IEA, the International Energy Agency, will update these numbers in their annual Hydrogen Outlook report next week. So basically, we will see if we go over 1% or not of electricity originating hydrogen in 2023. My guess is that the answer will be no, we will not go over 1%. But once again, that is the starting point. There's a lot of work to be done here, of course. And as emphasized, climate COPs after climate COPs, last year in Dubai, this year in Azerbaijan, and of course next year in Brazil, we urgently need to change because we're not delivering on the changes that people after the COVID crisis have requested all over the world. So the industry is quite late at this crucial rendezvous of decarbonization of the hydrogen industry, the existing one, and developing additional green or clean hydrogen capacities globally moving forward. There's plenty of amazing reasons that explain this reality. But if we break it down, really, it all goes back to these 3 points. There's a lack of market integration of hydrogen. There's a lack of general hydrogen literacy, which is hampering democratic debates about hydrogen all over the world, and therefore hydrogen adoption. And of course, there's a lack of climate action will from many stakeholders globally. So basically, the situation in hydrogen is kind of this. We don't know exactly how to make this whole thing happen. Conference after conference, we hear about the chicken and egg problem, blah, blah, blah. Well, there's no chicken and egg problem, in fact. South Korea is one of the very few countries out there in the world that does have a very comprehensive hydrogen strategy aiming for the right thing, creating demand. When you compare the geography of Korea, Japan, or Germany, you understand why these three countries, of course, need to import or will need to import hydrogen. This has been emphasized earlier on by Flora. But basically, this is important here. If you don't have a carbon tax mechanism, if you don't integrate the right externalities, especially the negative externalities costs, to the existing energy flows, then basically hydrogen will never be competitive enough. The discussion here is flawed from the get-go. And that is something that is quite often overlooked in most hydrogen conferences here. So I'm here to present you some work that I've been doing, of course, as an independent researcher on hydrogen markets and geopolitics. And also, I will be extending my presentation to tell you a little bit about what's happening in France. We're not the best in the world right now in hydrogen, but we might be on a good path towards something meaningful regarding decarbonization. All of that will be in a book that I will publish together with the Clean Tech Business Club, a private group of like-minded entrepreneurs and whatnot. On January 2025, we will present that at Hivolution Paris, the largest hydrogen exhibition in Europe. You're all welcome, of course. Basically, this book is based on more than 60 field trips all around the world, field research, including in Antarctica, as you can see. And there's plenty of research being done, 10 key messages. I don't have the time to share them with you all today, but what you can remember is that harnessing the complexity of developing a hydrogen, not just economy, not just society, but as our Chinese neighbors here would say, a hydrogen civilization, it requires understanding and explaining and having people understanding and adopting, harnessing this degree of complexity. This is how I see the hydrogen economy. This is how I see the hydrogen civilization moving forward. Each number here, of course, referring to some key element in unlocking this whole industry. So we need a systematic approach. And if you want to just remember one thing from this presentation, taking on from the experience of all of these field trips and studying all of the countries in the world that do have a hydrogen strategy or something that can be assimilated as a hydrogen strategy, these are, for us, my team and I, the key success factors in hydrogen, especially in clean hydrogen. Scalability, salability, security, sovereignty, the 4 S's, if you like, of clean hydrogen deployment. They're all based on providing proof to the investors, to the electorates, to the local constituents, providing proof. It has to be reliable, it can't just be words on PowerPoints. And this is extremely important right now, all around the world, in 2024, 2025. From a political science point of view, we are experiencing, maybe not everyone here in our day-to-day lives, but globally, we are experiencing an unprecedented moment in history. In 2024, 2025, we have the biggest democratic sequence ever, with 71 countries in the world being called to the polls to actually cast a ballot and effectively deciding whether we're going to go for a greener world or not. These are the countries in 2024. And these are the countries in 2025. Well, when it comes to Canada, maybe it's going to be even faster because Justin Trudeau is experiencing some issues in Parliament and might be overturned. But that's a different story. So, 2024, 2025, 55% of the world's population is called to cast a ballot. All together, they represent 59% of the global's wealth. Altogether, they represent 45% of the world's global greenhouse gases emissions. This is absolutely key. We are living a moment that is very, very important for the next years moving forward, that will determine from a policy point of view if in the 2030s we will be able to deliver a greener world or not. And where is hydrogen in all of that? Well, hydrogen is front and center in many countries in the discussion. From a global to a local perspective, with regards to energy production changes, market design evolutions because of hydrogen moving forward and getting into the mix. Transmission discussions. Are we doing huge power lines? Are we doing pipelines for hydrogen? Are we doing blended pipelines, hydrogen, natural gas? Are we doing none of that and actually just maritime flows? These are, of course, very important questions. Distributions, the place of consumers in all of these market design, all of these policies. Well, altogether, one key message from the book is that hydrogen is likely to re-centralize energy geopolitics. What does that mean? It means that basically right now we live in an energy world that is very much centralized into the hands of only a small number of either private, such as Chevron, for example, or public, such as Saudi Arabia, actors. Hydrogen is likely to perpetuate this centralization of the control of energy flows, politics, economies, only in the hands of a handful of actors. But they might be not the same actors as they used to. So it's been said before, and thank you so much for saying that, because then I don't have to spend too much time over this. Basically, projects globally, despite the pessimism, despite the naysayers, despite the very fancy guys on LinkedIn who keep telling you that hydrogen will never work, projects are still growing globally. All kinds of clean hydrogen. FIDs, final investment decisions, are also growing in all kinds of hydrogen, either applications, productions, storage, and whatever a type of business models. And that is in spite of the macroeconomic challenges, which are very much adverse the development of hydrogen. Increase of cost of capital, inflation globally, friendshoring, and the likes. But one thing is certain at the moment, and it's been said before, alkaline is leading. Alkaline is likely to keep leading. Even though it's not the best for the climate, we don't care. Here, the delta of efficiency between alkaline and some PEM or AEM solutions, it's up to 30 percentage points maximum. But the cost of an alkaline electrolyzer compared to a PEM, to an AEM one, etc., at the moment, well, it's 1/3 of the rest, of the competitors. So basically, at the moment, it's super easy to understand why alkaline is still indeed working, generating a lot of business. And definitely, who is leading in alkaline? Well, China is leading in alkaline. And they've been leading in alkaline for more than 50 years already. It's nothing new. This is a cost competition, the alkaline sector here. And they're going for pressurized alkaline, so they're increasing their technology levels as well. So they are able to answer to the new market needs, no longer with just atmospheric alkaline, but also pressurized alkaline. Anyway, this is the amount of electrolyzer in operation capacity in China. Compare it to the rest of the world in 2023. You see the difference here, and you see why. There's a lot of discussions, of course, in China, and why the discussion in China that might not be democratic, that might not be decided collectively, that might not be subject to the same electoral issues as in any other places in the world, you see how they determine where this whole industry, hydrogen, is going. So, can one country make a difference? In the case of China, because of the scale, the answer is yes. There's India also coming on this international hydrogen stage. And in India, well, the discussion, even though it's a democracy, it might not be super democratic. I mean, not as liberal democracy as what we have here in South Korea or in the West. But these two countries alone, they don't make the whole hydrogen picture. What you're looking at here is simple. At the end of August 2024, my team and I, we have identified 90 countries in the world with a hydrogen strategy at national level, governmentally sanctioned, an official one. There were only 15 in 2019. So this is a new map of hydrogen. Of course, in here, all the green countries on this map are those that have a hydrogen strategy. So it's not 45 countries or 50 countries or 55 countries, as I read in some reports. It's actually 90 as of August 2024. With countries that have a lot of potential indeed, in terms of production, in terms of storage, particularly underground storage, and in terms also of transforming that hydrogen into some semi-finite or end-use products locally instead of exporting the hydrogen. So if I break this down, this map, there's 5 groups for us of hydrogen countries from a geopolitics point of view or from a geoeconomics point of view. South Korea and France belong to the first group here. Countries without hydrocarbons nor enough renewables capacity for their industrial needs. So technically, ladies and gentlemen here, you and I, we're in the same boat. And we're even more so on the same boat that you want to do nuclear, and we in France want to do nuclear as well, which, for example, Germany doesn't want to do. So basically, we're really, really in the same boat, South Korea and France. But anyway, countries like Qatar in Group 2 or Brunei in Group 2, they will not go for green hydrogen. And they will keep on exploiting those hydrocarbons, of course. They will rely on technologies like that, like those of Chevron, for example, to actually develop the blue hydrogen value chain. Countries like Saudi Arabia, for example, or Norway, they could, in this third group, develop everything at the same time. But some of them are doing it, some of them are not doing it. And we'll go back to that. They're saying hydrogen is too costly to deploy. But when you look at it, and it's not me that's saying that, it's actually the financial and the insurance industry. They're saying, well, hydrogen might be costly, but it's less expensive than just business as usual and reaching +3 or +4 degrees Celsius of temperature rise by the end of this century. They're also saying, and here, it's not even the financial sector, it's not even in the insurance sector, it's the IMF, the International Monetary Fund. They're saying, maybe we're subsidizing hydrocarbons a bit too much for this whole thing to work. What you're looking at here is the total subsidies for hydrocarbons production and consumption since 2015 and projected all the way to 2030. Here, 2022, that's the last year for which they had robust data. Basically, what you're looking at here is a year in history in which hydrocarbons have never been more subsidized in terms of direct subsidies by taxpayers' money or in terms of indirect subsidies, meaning the people's health and the environment, than ever before. What we're talking about here is basically 7,000 billion US dollars of indirect or direct subsidies. 1,500 billion of which being direct subsidies. So when you compare that to renewables direct investments in the same year, well, we basically have pretty much the same renewables direct investments in 2022 as we had direct subsidies for the hydrocarbon sector. Okay. But more importantly, when it comes to hydrogen, the global low-carbon hydrogen subsidies, not just in 2022, but over the course of this whole decade, it's a mere 360 billion USD. So basically, there's no competition. And integrating, once again, I'm not the one saying that, it's also the IMF, integrating all costs of hydrocarbon pricing is very important if you want to have a level playing field with non-hydrocarbon, defossilized energy solutions. You need to include the cost of society such as pollutions, road accidents, congestion, the global warming costs, the foregone VAT, and the likes if you really want to have a real discussion. If you don't have this real discussion, you can't try effectively to increase the willingness to pay a green premium. In the book, we look at many industries, the auto industry, the washing machine industry, and many other things, groceries. We look at that to understand actually how much people are willing to pay for a green premium. That informs, for us, the discussion on hydrogen. We see that willingness to pay a green premium rises globally. And I'm reaching the end of my time, so that's going to be, of course, here the beginning of my conclusion. The willingness to pay rises globally. But it's cultural. In China, there's at least 3 times more people that are willing to pay a green premium than in Germany, for example. Just as an example. You'll know more, of course, in the book. What we see as well is that the willingness to pay is actually enough for some industries along the hydrogen supply chain to actually unlock this supply chain. Steel to automobiles, that's one of those in which the willingness to pay is enough today to drive the supply chain moving forward. And that's important, of course, for Hyundai, for example. We're seeing countries, as I said, especially in the global south, saying we need to produce semi-finite products locally instead of exporting the molecules. It has lower risks attached to it. It has higher in-country value attached to it. It's better funded than a pure hydrogen project. And these global south countries, they're no longer willing to export such raw molecules. There's plenty of many bottlenecks left. And of course, I don't have the time to dive into all of that. But just in maybe 1 minute, if you allow me to. Thanks to my friends before, I have maybe 4 minutes, 4 minutes to add to my time because they were short in their presentation, shorter than expected. Hydrocarbon rentier states are now confronted to a choice. And some countries are choosing to go the green path. Some others are not, definitely. Policymakers are confronted to a choice. Should we invest in green hydrogen now that new, cleaner hydrogen is arriving on the market, like natural hydrogen? I see some eyebrows raising here. In many countries, think Morocco, think Oman, think Colombia, think Australia, think France. This is a real discussion, politically speaking. Because it's just the beginning. And natural hydrogen is not going to replace green hydrogen or whatever. It's actually complementary. The amount of hydrogen we're talking about here is massive. But we'll get back to that, I guess, later on. And in a country like ours, we've had a lot of debates on whether we should recognize nuclear hydrogen as green hydrogen, whether Europe should recognize natural or nuclear hydrogen as green hydrogen. We've had that. What we realize now is that basically this geopolitical urgency that we have in Europe is, of course, flowing a lot of debates. We're demonetizing words here. It's important to give a proper definition engraved in certification models such as Certify, for example, or such as the certification model developed here by the South Korean government in determining exactly what it means to be green. And here, if you have a 4 kilograms of CO2 equivalent for 1 kilogram of hydrogen well to gate, you're not doing green hydrogen. If you're doing basically the same thing, but at least well to wheel, that's better. That's greener. And we need to have objectives, targets from a governmental point of view that are actually reliable. When the EU said in 2022, because of the Russian-Ukraine war, we need to have 20 million tons of hydrogen by 2030, this figure, it's based on nothing serious. It's based on nothing concrete. It's just political thin air. And now we're in a situation in which people in the hydrogen community are saying, we will not reach those targets, so hydrogen is not working. See, it's not working, we're not reaching the targets. Well, maybe the targets were flawed in the first place. Maybe the industry is still waiting way too much on taxpayers de-risking money to actually invest. But something are changing. Politicians, at least in Europe, they're broke. And they're tired of waiting. So they're moving away from the carrot perspective, going into the stick perspective. One way to look at this, one exemplification, is the AFIR directive on hydrogen refueling stations in Europe. Another way to look at this, another example, is the RED III directive. And of course, the slides will be made available to you so that you have the data. Or the RED II delegated acts, same thing. We can't mess around with hydrogen, it has to be green. And these EU standards, they're becoming global, despite fierce lobbying. And there's this, new legal pressure. In Europe now, we have tribunals applying pressure on European governments So governments are no longer like just responsible in front of their electorates. They're legally responsible for making this happen. This ruling from the European Court of Human Rights earlier this year applies to 43 countries in Europe, not just the 27 EU member states. So when you come to Paris for Highvolution in January, you will see that we have the world's largest integrated hub for H2 mobilities, with more than 600 taxis, with approximately 15 refueling stations all across the region. Maybe you've seen that during the Olympic Games that we've just organized with this hydrogen car during the opening ceremony for the Paralympics, for example. Maybe you've seen this station just by the Eiffel Tower, working open to everyone. Maybe you've come across this, Europe's largest hydrogen refueling station, 1 ton a day in downtown Paris. All of this is happening in here. We are changing. Not fast enough, but we are changing. Despite all the problems politically, economically, infrastructurally speaking, that I've mentioned since the beginning of my presentation. The government supports indeed hydrogen hubs across the whole country, like here in South Korea. Once again, no longer are we in the same boat. Maybe we're finding the same solutions, because just like South Korea, our role in the energy geopolitics in our region, Western Europe in our case, it's changing. And that's because of hydrogen. So all of that will be in the book. The book will be available in Korean, and I hope that next year we will be able to have an event specifically around the findings of this book here at H2 Meet 2025. Thank you so much for your attention. A massive, massive, massive 감사합니다.
네, 고맙습니다. 미카 블루지온 메레드님께서 오늘 강연을 들려주셨는데요. 탈탄소를 위한 수소에너지 경제 활성화와 또 수소산업 발전 계속해서 그 중요성 커지고 있습니다. 시장 통합과 수소에 대한 더 깊은 이해 그리고 역시 협력에 대해서 강조해 주셨습니다. 고맙습니다. 자, 이어서 키노트 세션 마지막 강연이 되겠습니다. 이 블룸 에너지의 Head of Development Engineering이신 칼 코듈리님께서 Charting Pathways for the Sustainable Future라는 주제로 강연 들려주시겠습니다. 여러분 따뜻한 박수로 환영해 주시기 바랍니다.
All right, thank you for having me here today. I'm extremely excited to be here. Got a lot of things to talk to you about, what's been going on at Bloom Energy. You know, Bloom Energy is a manufacturer. We consume hydrogen to make electricity, and we can consume electricity to make hydrogen, and we're going to talk a little bit about some of that today. Next. Is that my responsibility now, I take it? Yeah. All right, there we go. Oh, that's me. We don't need to get into that. So talking a little bit about the actual Bloom as a company. We're global. We started in California. We've got manufacturing across the globe in San Jose, in Newark, Delaware. We've got sales offices all over the globe. An engineering team. I run the engineering team. Our engineering team is based in San Jose, Delaware, Mumbai, and Bangalore. We've been working on this technology for over 20 years. And one of the things I'm proud to say is having been at Bloom, being a critical part of the engineering team, we've got a lot of success. As you can tell, last year, 1.3 billion in revenue. I've got a little over 1.2 gigawatt of the fuel cell technology deployed. And going on, I think it's that way. There we go. These are some of the customers that I'm deployed in. You know, why is this important? Well, because I make electricity, I can do that with natural gas or hydrogen. I'm attracted to a bunch of different companies. It's no longer just one market. Anybody who consumes electricity is a possible client for our fuel cell. The good thing about our fuel cell attracting to these companies is its resilience and high reliability. Some of these will look familiar to you, and again, these clients are pretty much all over the globe. All right, one of the things about the technology is extremely flexible. It's an electrochemical process. So like I was saying earlier, I can give the process electricity and it'll produce hydrogen, or I can give it a hydrogen molecule in any form and it'll produce electricity. Currently today, most of our deployments are with natural gas, and I'll strip off the carbon and react with the hydrogen to make electricity. And that's what you're seeing about a variety of different inputs to my product. And I can use it with biogas, hydrogen. It really doesn't matter to the energy generation product. But I also can deal with intermittent sources. One of the speakers were talking about, you know, a 20% minimum on some of the other electrolyzers. Ours can go down to either 0 or 5 just to keep it at the ready. And consequently, I can do that with electricity. I can ramp it up. I can ramp it down to support my client loads in whatever form it would come in. Obviously, on the output side, really like to see the AC at different voltages, the DC power, ideally. Fuel cells are a natural DC generator, even when applied with flexible voltage or flexible current. So, and obviously what we're talking today is the hydrogen production side. So, solid oxide technology. What's one of the big benefits of this technology? This is a fuel cell technology that we've been working on for a while. Like I said, we got a lot of it deployed. Whether it's the fuel cell or an electrolyzer product, pretty much this system is exactly the same. Why? Is it one of the most efficient products out there? It's because of the better reaction due to the higher temperature. The reaction kinetics that are happening on a solid oxide fuel cell are up in the 800 C range, consequently making it very efficient. And as I look to my product and scaling it, one of the big barriers to scaling is specific metals. I don't use any special metals to make my product. It's all readily available with long and mature supply chains. And of course, in electrolysis mode, steam input. Right? One of the things you can do on steam input, and as a message back to where Chevron was saying, I was missing a big line that came out of that reformer into the electrolysis, because that steam and that heat can help with the electrolysis system in SOEC. And again, there's no hydrogen bond as I take in the steam. It's just a covalent bond that's relatively easy to break at that temperature, and I'm able to produce hydrogen. So, as I look at this as a generator, one of the things I'm constantly trying to improve on the fuel cell is how efficient I am, right? Where I'm fuel flexible. I can start off on natural gas, convert it to hydrogen at any time, and make that energy being produced around 54% over its lifetime. Day one operation is nice to talk about, gives you good numbers in your math, but over the operational lifetime of a system is really where the action is when you're doing total cost of ownership. And then, of course, if I'm running hydrogen, zero emissions, as we had talked about earlier, that's the goal. That's where we'd like to see the world go. And I'm able to get there with natural gas first as the first take for a client to be able to come on board and have a path to net zero. So one of the other things to be thinking about, obviously in the combustion side, when comparing, is NOx and SOx emissions, relatively non-existent. All right, so some of the overview, as I look at our input sources, I heard the previous speaker talk a little bit about nuclear, right? And being in France, I imagine that's probably a big thing. However, I also see it here, as a global potential for electrolysis, because nuclear systems have a lot of curtailment time. Even if you're just using their curtailment time, can produce an awful lot of hydrogen. Consequently, I can take in wind, I can take in nuclear, and of course, I can take in solar, and all of it can be intermittent. I don't need them all together. I don't need them all the time. As long as you give me the watts, I'll be able to produce hydrogen with the electrolysis. So ideally, in that process, I'd like to have an input of steam. If steam's available, as you know, if I'm doing any type of SMR action, then there's plenty of steam available. If I'm in a nuclear plant, also plenty of steam available. If I got a ammonia plant on the output, again, plenty of steam available. Right? So again, all that drives into the efficiency of a total solution. Now, I'm not going to go make the ammonia plant, right? I'm fine taking in my steam into my product, but I'm not going to do the total solution. I'll be part of a partnership with a developer, and I can bring the fuel cell to the table. So overall, 40% more efficient than low temperature electrolyzers is really where we target. With that, so let's talk about the Bloom solid oxide electrolyzer. We've been working with the national labs in the US quite regularly. We have a lot of time and a lot of discussions with them. We've done tests with them. I'll show you that in a minute. But ideally, on these labs, being able to validate solid oxide as a viable electrolysis product. And that's what we've been working on. All of them, in the green states that have a national lab that have applied for the hydrogen hub in the US, we're part of 4 of them, and in a major significant way. And these are at scale. Okay, so let's just talk about some of the technical details of the electrolyzer product. Well, number one, the efficiency, right? The efficiency at 37.5 kilowatt hours per kg, extremely important. This is where really the benefit that I see for solid oxide. That over the lifetime outweighs any type of capital, and we're back at work constantly on driving down capital. One of the best things for solid oxide is that there's still a lot of development going on to be able to drive down that cost. I've been at it 20 years. I'll continue to stay at it, and I'll continue to drive down costs. I'll get pathways to continue that process at the aggressive rate I've been on for the last 20 years. So one of the other things, and that's really the estimated learning rate math that we're alluding to. But some of the other key metrics, as I look at the material availability, right? We had spoke about this earlier. Not a lot of special materials in a solid oxide product. And I've got really a high capability in my supply chain, and it's very robust on the material set. And like I'm always concerned about is where the next development is. How do I scale? Can I scale today from my current manufacturing capability? And the answer is yes, because I've got the ability to not only ramp up my manufacturing process, but my supply chain standing there behind me. So that gives you a little bit of idea why we see SOEC ready for that scale. So this was a demonstration. There was a mention earlier about solid oxide not being out there and running anywhere. We actually built a 4 megawatt plant, and this was at a NASA test facility where we were based there, installed a large plant, gave it all the electricity it needed, and continued to run a hydrogen test at 4 megawatts. This is just a little bit picture of it. The text is covering up the other side, but that one block there is 2 megawatts. There's another one of those sitting on the other side outside that picture frame, just to give you a little idea what that would look like. So how do I do it? Had I thought about it, I would have brought the a piece of a cell with the ceramic and a piece of metal. I bond these two together, and I just stack them up. Hence, I call it a stack. Very simple. And I take many of those stacks and I put it into a box, and I call that a module. And then I put as many modules as I need. The power density is constantly going up. The cost is constantly going down on these products in a main scale manufacturing. one of the best things you can look at is I've got a 2 megawatt plus capable manufacturing facility. I've got enough capability to be able to double that if I need to in the coming years. And it's only going to take me a year to double it. So I have a lot of horsepower, a lot of capability on what I can do with the product, my supply chain, and my manufacturing to meet that demand. All right, next, monitoring. We do a lot of monitoring. We monitor all our sites. We have remote control centers in India and in the US, where that 1.2 gigawatts of deployed product, I can fire up my laptop, log online to the RMCC, and see the operations and the performance of any site. And that data is constantly updating. That's important for me to be able to drive continuous improvement. Right? And I don't have to always have contact. I can make it a gateway. I can put a data diode in for whatever type of protections, but the whole idea is to improve performance, and I have the ability to do that at the power module or the energy server or the system level on how I deploy it. Like, because I have a system and it's not monolithic, I can if I have 100 megawatts deployed and you only have 50 megawatts of solar today, I only have to start half the units. I don't have to start them all and run them at half. I can make different decisions about optimizing my runtime with this type of technology. One of the other things that we do on our natural gas fuel cell, where we're taking in natural gas and producing electricity, is we'll do heat capture. This is one of the things that we see as driving up efficiency. And if I'm taking in hydrogen, I'd argue with you that that is green heat that you're going to get out of my system. And if you have it at all a need for heat, you should be using the green heat, because that directly offsets other watts used for some other heat or some other petrochem to be either run a boiler or something along that line. So direct capability to get 350, 400 C exhaust from the collection of fuel cells. Now, the other nice thing to be thinking about, again, because I'm modular, you don't need to put heat capture on all of them. You can only put it on some of them, if that's what you wanted for the amount of heat you think you need. So you're not forced to take all the heat, but you could if you wanted to. So ideally, a lot of customers take it into an absorption chiller, just to have chilled water running through a building for air conditioning. Others will run it into a tube for a heat exchanger for building heat. That happens quite a bit. Or boiler preheat will happen a lot as well. So that's one of the thought processes. So I'm just going to go back. One of the other things I would just want to talk about, because you guys did cover a little bit on carbon capture. I know you weren't really looking for that, but I have the ability in my the fuel cell to separate the carbon stream. Why do I have the ability to separate the carbon? Well, as I had mentioned earlier, as I break that carbon-hydrogen bond, I have the carbon available to me. The hydrogen is bonded with oxygen, and my airstream, unlike combustion, are separated, meaning I always maintain a separation between my cathode and anode airflows and streams. Consequently, the resident CO2 that I've bonded with free oxygen is sitting in a stream almost by itself. I strip water out of that, I'm in the 60% range in the CO2 stream, making it very advantageous for carbon capture technologies. All right, manufacturing facilities, just talk a little bit about this. This is our Delaware facility. This is a pretty decent sized building, not fully consumed, but you can see the open fields on each side. That's all our land to be able to drive expansion into that Delaware facility. Out of the Delaware facility is where the finished goods come. And so everything will come out of there. And then if I look at the Fremont, California BMCC building, this is where I'm doing the actual cell print. This is where I'm building that stack and that column to be able to put in a box. And all of that, all the putting it in the box happens in Delaware, but I actually print the cell, make the stack in Fremont, California. Both high volume manufacturing. If you're familiar with manufacturing techniques, the BMCC cell manufacturing will look a lot like a semiconductor line, and the Delaware factory will look a lot more like an appliance line. And then, of course, I've got my Bloom SKGV in Gumi, Korea. We look at this as a critical step of integrating Bloom products into the Korean market. We get a lot of benefit out of this facility, where we can send our products there. They do the finished manufacturing in this Gumi facility for the Korean market. We're also integrating vendors for the product out of the Korean market as well. Some of our critical vendors are already based in Korea, and we actually use them in our global product, not just the Korean product. So with that, what do you know, my timing worked out. 2 minutes left for questions. Any questions? Everybody's got that? You're now educated on SOEC? Go ahead.
Yeah, translate, please.
Would you please put your receivers on? I believe it's there behind you.
All right, go ahead.
오케이. 오늘 설명 감사합니다. 그러니까 조금 전에 우리 쉐브론에서도 말씀해 주셨는데요. 그러니까 미국은 석유와 가스를 정말 전 세계 한 75%를 컨트롤하지 않습니까? 그러면서 석유와 가스만 해도 충분하고 제가 볼 때는 굳이 뭐 수소라든지 전기차로 가지 않아도 된다고 생각하는데 우리 대표님께서는 봤을 때 왜 미국이 이런 블룸에너지라는 수소라든지 이런 쪽으로 가야 된다고 생각하시는지, 그리고 경제성은 언제 이제 보조금 없이 맞출 수 있다고 사업가 측면에서 이렇게 보세요. 네, 감사합니다.
Okay, so multiple questions in there. I'm going to try to peel it off. If I miss one, come back to me, all right? So yes, U.S. is very much prevalent in the, petrochem world. Everything, a lot of electricity is developed through petrochemicals. All the cars run that way. But electric cars are rising at a rapid rate, at a really rapid rate. And the grid is getting stressed. And it's constantly getting stressed. My number one request that I see from customers for our product in relation to responding to that stress is time to power, or the utility company saying, hey, I've got no power to give you. I've got no transmission lines, I've got no distribution, I've got no core generation. So that's why I see a big market for us to be able to not only serve end users, but serve the EV market as well. Every one of them that I'm talking to is aware that the hydrogen market is coming, and they want to know they have a path, right? They want to know that there's a path from consuming natural gas to be able to do the same thing consuming hydrogen. So that pathway that I'm able to do with the product is what makes them attractive. Now, the other thing you had mentioned is profitability without subsidies, right? On the financial side of where we are with Bloom. Yes, right now the ITC credits are there, but we're also doing that in Korea. If we wanted to start talking about cutting, subsidies for any one of the other new developments, that's certainly a discussion we can get into. But what I will tell you is that the cost down drivers that we're working on now get us well below the ITC benefit, including profitability. So we've got a roadmap to get to that point, and we're constantly working on it. And that's really my responsibility in the company. There's plenty of others in my Korean teams here that it's working with the Korean market. So, but good question. Thank you for asking that.
정말 미국 정부는 수소를 키울 마음이 있습니까?
Give me a second. Hold on. Go ahead.
정말 미국 정부는 수소를 키울 마음이 있습니까?
Okay, do I think the U.S. government is serious? You know, I think all of us have talked about the political uncertainty happening in the U.S. You know, I'm serious about it, and I'm a voter. I'm going to vote for that, right? You know, and it takes all of us to be able to push that. But do I think they're serious? Yes. I just don't think they know what to do, right? You know, they've issued a big subsidies. They know what they want to do. They just don't know how to set the rules. So the one, there's no bad behavior, and two, it's fair and equitable. I expect them to get there at some point. It may take longer in the current political sector we're headed towards.
All right, thank you very much. We would like to take more questions, but because of the time constraint, we have to wrap things up from here. Thank you very much for your presentation. And ladies and gentlemen, please give him another round of big applause. 네, 수소를 활용한 지속 가능한 미래 경로를 모색하는 방안에 대해서 알아봤고요. 특히 환경적 그리고 경제 지속 가능성을 동시에 달성하기 위한 혁신적인 전략법에서 알아봤습니다. 자, 이렇게 네 분의 강연 함께 하셨습니다. 수고해 주신 연사분들께 감사의 말씀 드리겠습니다. 이상으로 리더스 서밋 키노트 스피치 세션 마치겠습니다. 잠시 후 2시부터는 이곳에서 토픽 1 코리아, 재팬, 차이나 하이드로젠 모빌리티 포럼이 진행될 예정입니다. 오후 세션에도 여러분의 많은 관심 부탁드리겠고요. 참가자분들께서는 1시 55분까지 이곳에 다시 자리해 주시기 바랍니다. 즐거운 점심 식사 시간 되시기 바랍니다. 잠시 후에 다시 뵙겠습니다. 고맙습니다.